All right, let's talk about a concept called normalization. Now, this is a really important topic. It's going to help you grasp exactly why and how data models actually work, but it can be a little bit tricky to wrap your head around at first. So, the textbook definition here is that normalization is the process of organizing the tables and columns in a relational database to reduce redundancy and preserve data integrity. So, what the heck does that even mean, right? Well, it's commonly used to do three different things. First, to eliminate redundant data in a model, to decrease your table sizes, and more importantly, improve processing speed and efficiency. It's also used to minimize errors and anomalies when you do things like insert, update, or delete or otherwise modify data inside of your model. And third, it helps simplify queries and structure your database for meaningful analysis. And we'll see examples of this as we start writing DAX queries and measures later on in the course. So at this point, it still feels a little bit vague, right? A little ambiguous. So the way that I like to wrap my head around what normalization really means is to think of it this way. In a normalized database, each table should serve one distinct and specific purpose, and one purpose only. So you may have a table that only contains information about individual products. You might have another table that only contains daily transaction records, another that's a calendar table with information about dates, and maybe some others that contain attributes about your customers or your stores, and so on. And these should sound pretty familiar because these are the exact tables that we'll be working with in the project that we work through throughout this course. So let me take a stab at kind of bringing this to life and visualizing the concept of normalization a bit. Imagine a table that looks like this. You've got transactional records here, right? You've got dates of transactions, product IDs that were sold, the quantity of goods sold, but you also have product-specific attributes stored here as well, like the product brand, the product name, the SKU, and the weight. And because you have multiple transactions per day and multiple transactions per product, you end up with a bunch of redundant duplicate fields or rows here. In other words, every time a specific product ID is sold, we're storing the same set of information about the brand, the name, the SKU, and the weight in row after row after row. And you might be looking at this and saying, what's the big deal? Like, I've got all the information that I need for my analysis. I've got it all in one place, so that's great, right? But suppose that instead of a handful of records like we see here, you've got 100 different products that sell an average of 10,000 times a day. Now we're talking about upwards of 1 million duplicate rows for each date in the table. So the point is that minor inefficiencies like this can very quickly become major problems as you scale. And the way that we would solve a problem like this is to normalize the data, right? We'd take all those product-specific attributes, brand, name, SKU, and weight, and we would store those in its own separate table containing one row or one unique record for each product ID. That would essentially transform this one table into two tables that each serve one purpose. You'd have transactions with date, product ID, and quantity in one table. You'd have products in a second table, and you could use a relationship between those based on the product ID field to access the exact same information without any of the redundant data. So hopefully that helps. We're going to walk through a ton of additional demos and examples to help really hammer this point home, but that's our introduction to the concept of database normalization.